Hi everyone, hope you guys are doing good. In this video, we are going to talk about the system design of DevOps-Xlabs. I am going to explain how am I able to create these labs, how are you actually accessing them, and all of the tech behind these labs. But before we continue on this discussion, it's very important that you have previously watched the introductory video that I created for DevOps-Xlab. If you have not watched that, just go back, have a look, and then come back here. A lot of things will make sense and you will be able to understand the technicalities more easily. However, if you have already seen that, then let's get started, okay? So this is, I'm sharing my screen. This is how DevOps XLab looks like. This is how the platform looks like. And the platform, as you guys already would be knowing by now, is for DevOps engineers where they can practice labs. Labs are nothing but an interactive terminals where the actual day-to-day tasks of DevOps engineers are mimicked in terms of what we actually do. If you are somebody new, then you will start from the beginner's guide. If you're experienced personnel, then you will take the different action items or if different tasks as your requirement may be. So for the context of this discussion, I will just open any of the labs. It doesn't really matter for us. I would open, let's say this guy here. So basically in this lab, what we are doing is we are installing or we are doing a setup of Kubernetes. And just so that we are on the same page, I'm explaining this, but this is already covered in the introductory introductory video in much more detail. So you will have on one side the theoretical part, the practical questions and interview questions and resources. Resources are basically the scripts that you can use. And the actual work that you will be doing would be in this practice session. So as soon as you click on the practice session, what you will get is a environment, a terminal, which is not a Kubernetes pod, it is not a container, it's actual VM that you are getting. It's a KVM. There are two type of VMs. One is a hypervisor-based virtual machine, another one is a kernel-based or KVM machine. This is what that is. So in this video, I'm going to explain how DevOps XLab is actually working, what is the tech behind it, how am I creating these labs, and most importantly, how is all of this free, and how are you able to use these labs without taking resources from other people who are or who might be using it. At this point in time, I have uh, about 2,000 folks who are registered, and these are the labs that are going on right now. One is a demo lab, and another one is the actual personnel lab who is using it. So, like that, it's an early Sunday morning. Generally, we see traffic in the daytime when I can concurrently support around 12 to 15 labs. So, without making further ado, let's start the discussion by going to the whiteboard and I'll explain you all the first I'll give you a brief picture like a simple version of this and then I will give you a more detailed version of this what is happening in the backend. All right, so let's get started with the terminal. Okay, so first requirement for us or for anybody who is creating such kind of lab is that you will have your user. So this is you or this is any user of DevOps-Xlab, and they will of course be connecting to their internet service provider, and from there they would have a DNS. In our case, that is DevopsXlabs.com, and that DNS would be resolved to some endpoint, let's say for some server, and this server would be hosting on the particular name server and giving feedback back to the user. So this is generally how client-server architecture looks like, or you can say how 99% of internet traffic works. And then there would be some processing that would happen if there is a firewall or if there is a proxy, then this guy would act as a firewall or a proxy. And in the backend, it will be redirecting traffic to multiple other servers or multiple endpoints. If this is a microservice, then there would be different microservices that would be returning the responses back to the main server. And then the main server will do all of the networking and all of the patchwork and send it back to the user, and the user would be able to, let's say in his laptop, be able to do whatever actions the user wants to do. Now, in our case, the architecture on high level is also the same, but there are certain limitations, or let's say certain requirements that the user has from us, where the user actually does not want only the response back. What they also want is a session back. So as you saw, when I created a lab, you got a terminal back. Now, this terminal is actually an interface for the user to connect to a virtual machine, very much similar to how AWS or Google or Azure provides their Cloud Shell interfaces. So, this user here is basically having a client in that. um, in this example, the client is the browser. Okay. A client can also be a terminal, like if you are using Putty or Mobix, these are also your client. If you're using a curl command, that's also a client. And these guys, these clients are connected to a server, right? The actual server, it can be here, which is like the direct endpoint, the DNS endpoint that you have, or it can be any one of them. The microservices, some of that might be a UI port. Let's say this guy is a UI, this guy is a backend, and this guy can be your database or application layer. And here is what you are actually getting the response, or this browser has a server setting here. For our discussion, let's say the server is sitting directly here, even though it is not. I will explain that. So basically, your client and your server is having a communication, and now that communication is happening over a browser, and that browser is able to access the underlying infrastructure or the underlying environment of your server using a tool, a technology, or you can say a utility called Xstream. Okay, so the first core building block for us is Xstream. Let me show what I mean. It's called xterm.js. So if you guys are familiar with xterm.js, then that's an advantage. But if you are not familiar with it, that's also fine. Basically, in any laptop, if you install this package can be installed with npm. It's a JavaScript package. If you install this, and it's open source package, what will happen is that in your browser, there would be a specific port, let's say 8000, and in that port, when you when you have the Xstream running, you would be able to use the Xstream terminal from the browser. It is similar to as if you are doing it from a terminal like this. So here, if I have a terminal, I can access all of my underlying system resources. Likewise, if you have Xstream running, you can access the underlying system resources, or you can access the underlying terminal directly by the browser itself. Excuse me. So that is the first principle that we have, because what we want is not only an API response back, we also want a terminal back, right? So every user, let's say there are, as I showed you, there are about 2000 users, and we have created more than, I think, 3 to 4000 labs for now. So every user, when they connect to the server, all right, this is user, let's say one, this is user two. The user two will also again connect to the internet service provider, and then from there, again, they will connect to the server, and then from the server, there should be another session created for the user. Now, this is very important for us to understand in plain English language, and then I will explain it in the technical terms. The user has to be separated from one another. When you run Xstream, you cannot separate a Firefox browser from a let's say Safari browser, because this is your running on your own laptop, or let's say on a shared server. You will not be able to separate between the sessions unless you have some kind of a session management inbuilt in the system. So X number of users, let's say user 3, everyone is going to have their own backend server. Okay, so this guy has its own backend server, and backend server is nothing but a KVM. So user 2, again, all of this process will happen, and they will also have their own KVM. And for user 1, again, their own KVM. So all of these KVMs are going to sit inside the main server, or if it is a microservice-based architecture, like I said, then there would be a particular dedicated server for this to manage this, and we'll talk about it later. But for now, just understand that the first tech that is getting used is called xstream. Fine. So let's move this up. Let's take two users as as the use case. So this guy has his laptop and connects to the backend, right? And the backend is a KVM, and he's now able to do whatever they want to do. Then for another user, he or she is again getting their own KVM, and they're also doing whatever they want to do. There's a total isolation between these two processes. So this guy is doing all of the labs, and here again, all of the labs are totally separated from one another. So how are we able to do the session management is the next topic, but first we have to understand that how are we able to create the terminal response back. So first tech, let me write the tech stack here. First tech is xterm.js. Okay. The second one is there has to be somebody or some process that is going to manage these guys, right? These KVMs that I'm creating, I only have X amount of CPU and memory and resources in the backend. Now, if all of the CPU and memory is going to one particular KVM, then the others would have a problem, right? So we started with uh, a, a process, or let's say an approach, where we decided that, okay, all of the backend KVMs or all of the backend resources we are going to create with something called Docker in Docker. Or let's say I was thinking that I would have a Kubernetes cluster, and that Kubernetes cluster would be running all of these KVMs or all of these resources that I need as pods. Because I come from a Kubernetes background, this was my default choice. So either Kubernetes or I was thinking Docker. So I would have some kind of a Docker management or orchestration done by Kubernetes to manage these KVMs. So if there is another, let's say, a resource or another user that is needed, not necessarily KVM, it could have been just a simple pod and then give the resource back to the user. But then it didn't felt right. The reason was I don't want people to directly jump to Kubernetes, and I don't also want the labs to directly start from Kubernetes. You will be only a good DevOps engineer when you are hands-on with the core VMs. Like you saw here, this is an actual VM. This is not a pod, not a container. This is a VM. And if I created my labs based on underlying Kubernetes, even though I could have created and have Kubernetes managed these as individual pods, there is a risk. I'll talk about that. The risk is called privileged containers. All of these would have only worked if they were privileged containers, but I could have managed that with service accounts. However, the problem was you wouldn't be able to get the actual raw feeling of a VM. You couldn't be do things like mounting a volume. You couldn't create scripts which are outside of your scope. You couldn't run them. And I was only going to limit the user. If you see the labs that we have, these are not only related to Kubernetes. We have labs on networking. We have labs on, for example, infrastructure as code, where we are teaching people how to do terraforming or how to write infrastructure as code. This is not at all possible if you are inside a pod. So the second thing I wanted was a management solution for my individual users or the individual user resources, and this is where I looked into Wayscope. For some reason, I just keep calling WaveWorks as WaveScope, but it's called WaveWorks. And to be honest with you, this was a new concept to me. I didn't know about the fireworks or the VMs that are created by Firecracker micro VMs, this guy here. And this was like a crazy topic for me because I came to know that AWS is also using the same tech behind its micro VM management. So it's a solid footprint for any lab management system. And to me, this was given by Ivan. This is Ivan. I am sharing him on the video. Excellent labs that this guy has. He's a founder at, uh, I don't know how to pronounce this, Easy Moose Labs. Maybe I just pronounced it haywire, doesn't really matter. But these labs are awesome. You please check it out. And a big shout out to my friend. Thank you for helping me out here. I was initially thinking about doing it in pod on pod, or like I said, Docker in Docker. But then I realized that um, these tools that are created there by the micro VMs, like I said, Firecracker VMs, it's a open source KVM implementation. You can read about this here. Not that straightforward, I must say, like for you to manage, but definitely it's worth giving a try and understanding what is happening. So let me summarize it. What is happening in these management system is like, think of it like a Kubernetes of VMs. So here you are actually creating KVMs using the Ignite or Firecracker management system. So there is a CLI which is called Ignite, and this CLI is what I am going to explain in detail, because this CLI is what I am, or let's say CLI and API call is what I am doing in the backend. So I replaced my entire architecture. By the way, 3 months of work. I changed that, and I removed the DND and I started using the KVM, and it was the game changer for me. All right. So now I have uh, extremes, I have KVM. Now I need some kind of a code to manage this, because KVM does not know how to give the session back. Extreme does not know how or what kind of interface I want it to behave it in. So I had to write my own code, and this is where the actual grinding started. So now, to put it in simple terms, we have a request. Now I'm replacing the user with a request. So we have a request to a login. So basically, when you request any web page or any web server, you are checked for authorization, and you are checked for authorization and authentication, right? So first we had to think of the backend architecture, and then the normal kind of things, where whether the user is a registered user, how do I segregate between a registered user and a bot attack, how do I separate from normal users versus abnormal users. This is where I had to implement an authorization and authentication mechanism. And that brings me to the third tech, or let's say component in my discussion, which is called Firebase Studio, or you can say Firebase in general. Again, amazing solution, Fire Studios. You can do a full stack development with Fire Studio. The paid version is absolutely great, but the free version is also good enough for you to start. I don't quite like Gemini, to be honest with you, so I didn't rely on the intelligent code assistant that they had. For that, I used something else, and I'm going to discuss that a little bit later. But again, this was kind of an eye opener for me because what they are actually providing is they have a lot of building blocks already available. So everybody needs a mail authorization and authentication. Everybody needs a database. Everybody needs some kind of a logging system. Everybody needs some kind of authorization system. These are the blocks for any web application. Now you can either write them on your own or you can import it as a service. Right? You focus on your business, you focus on your idea, you focus on your tech stack. These common things like login, authorization, authentication, notification, monitoring, you hand it over to this stack. Let me log in and show you how it looks like. All right. Do I have, let me open without the studio. Uh, Let me open the docs first. I think that would help. All right. I want to show you what all do they offer. Let's say Fire Studio console. Perfect. So if I go into the studio and let's go into the console first. So if I go into the console, you will see that there are a lot of plugins that are available for me. Now, these, of course, you need to know when to use what kind of plugin. That's I think understood. But if you see, I am in a Blaze plan, which is like pay as you use, but you can start with your normal plans, right? So there are a lot of keys here, so I am going to hide. Uh, I have to hide my screen. Let me just remove and go to the extension part. This is what I was talking about. A lot of extensions are already available to you, and then you can just simply pick and choose what do you need. All right, I need to have some kind of plugin with my payment system. Okay, good. Go and use Stripe. Say in the future, if I want to pay my users, I don't need to build a payment solution. I can just install it directly and it will be available for my website. Excuse me. So those kind of things are available, and I could just focus on my logic. So we have Xstream, we have KVM, we have Firebase, and then we have one important piece to talk about. So let me just complete this picture here first. So I am requesting the service from an external vendor in this discussion. So authorization authentication is happening by a vendor. That vendor is giving the results back to me, right? And once I authorize and authenticate, then I allow this request to go forward. So let's say this is the validation, and once this validation is done, then it goes to the actual server. Okay, then in the actual server, now we need to have a controller block here, which is going to create the sessions. Now this is my own code here. I have to again write my own code here. Server block is not one piece of code, but it is multiple codes. All right, so we have a request, we authorized it, we validated it, it went to the server, and then the server in this case, we start with the UI server, and then there is a backend server, and UI and backend, of course, they have to talk to each other. I'll explain that again, and then there are certain controllers. Like I said, the controller that we are using for managing our KVM is one example of such. The another part which I said is very crucial for us is on the network side of things. How do I restrict or how do I protect my environment from the outside? That's again very important because I am giving sessions or I am giving the terminal access to users. How do I make sure that the single user is not creating multiple sessions or there is no bot attack on my endpoint? So for that, I have included another component in my system architecture, which is again from Cloudflare. Again, I have tried to use services or open source. Like for example, this is a service. Again, I'm using Cloudflare as a service for my DNS and my network protection. KVM is, like I showed you, it's an open source, and Xstream, that's again my open source. So these are basically all the pillars that I have, which I am using, and I'm not writing code to do anything in this part. All the code that I am writing or all the application level code that I have, they just implement or extend the use cases of these pillars. All right. So let's create a simplified version now. In the backend, what I have is my UI. All right. UI is simple HTML, and of course, it has JavaScript and all that stuff. So let's write HTML plus CSS plus JavaScript and TypeScript. All right. So this is the UI, and before a user reaches to the UI, a user has to be on the internet, and they have to have the connectivity to the DNS. Once they reach to the UI, then I ask them to log in. Login is again authorized and authenticated. Authorization and authentication is done by third party. So I'll mention here third party. All the third parties I've already shown you. Now, the code that is on the UI side is totally written by me and by the AI agents. Then this UI is calling a backend, right? And the backend, what is this responsible for? This is responsible for creating the API calls. Now, API calls are created to the KVM, okay, the Ignite solution, or let's say third party again, right? These third parties are then, in this case, the KVM is then responsible for creating the individual isolated servers, the VMs, one per user, and then it gives it back to the server. All right. So it gives it back to the server here in terms of a session. And then it is the responsibility of the backend to give that session by using uh, Xstream. So here we have Xstream component, and that Xstream component, the URL, because here now it would be a session-based URL, is given back to the user. So it, let's say for example, S Nadeem has logged in, so it will be like S Nadeem session and then DevopsXlabs.com. If somebody else has logged in, then it will be there, let's say XYZ slash whatever token is there slash DevOps. That is the role of Xstream. Okay. Now, if I break it into one more step, if I break it into one more layer, so you understood the third party components, you understood the code components. Let's understand the infrastructure components. In order to create a KVM, a VM, you have to have a bare metal server. What that means is you cannot use your VMs. You cannot create VMs on top of VMs unless these VMs have direct access to the actual hardware. Let's say I decided to create an EC2 machine and I want that EC2 machine be my backend. That is not going to happen because that is a hypervised or that's a VM in a VM, and I cannot have that kind of infrastructure. Again, if I need to have this kind of infrastructure where bare metal machines are available on either cloud or either on-premise, then my system design becomes a little bit more complicated. If I want to have this backend on cloud, then AWS is charging me around $4,000 per month. The bare minimum is, I think, i3 Metal series, and it's about $4,000. If I go to Azure, even expensive. If I go to Google, even more expensive. So the other option that I have is I build this bare metal, the backend server, on my on-prem setup. Now, how do I do this on my on-prem setup? If I have to do it on my on-prem server, let's say my laptop or my any existing server, that guy needs to have a IP, right? So the UI components and the backend components, they can either be on the same server or they can be on a different server. For the So let me highlight the UI, what I'm saying. So this guy and these servers, they can be same machine or they can be different machine. It's a bad design to have them on the same box because you don't want the lag in the UI to affect the backend, and you don't want the lag in the backend to affect the UI. So what I decided to have was an architecture which is the user hits the Nginx, and it can be any other proxy as well, but I am comfortable with Nginx, so I used Nginx. In the Nginx rulebook, I have addresses of these servers, right? So I have the address of the UI server, I have the address of the backend server. Now, both of them need to have IPs which are within accessible premises of my network. If I am having the public IP, I can do it by that. If I'm having the private IP, basically they should be able to communicate to each other and they should be in a separate server. So this guy has a known IP and this guy has a known IP, and UI knows where the backend is and is also able to access it. Internally, my UI is then having Docker containers. Of course, there has to be some flavor of Kubernetes and container. I am managing the UI part of the code, basically the static part of the code with the Kubernetes cluster. So this is managed by Kubernetes, and the endpoints that the backend has, these are actually sitting in my in my home. There is a big server that I just purchased, and this server is acting as a backend server, and it has about 24 CPUs, and it is about 128 GB of memory, which is allowing me to create individual sessions, and those individual sessions then create individual KVMs. Now, all of this KVMs, so this is backend and this is controlled by Ignite. And I showed you Ignite as a third party, and then there are individual KVMs. So individual KVM is again trafficked back to Ignite, trafficked back to the backend, and then the backend is actually giving it to the UI, whoever is calling it, and that is giving it back to the main load balancer of the UI, and from there it goes to the Nginx, and then from Nginx it goes back to the user in terms of a browser session. So this in a nutshell is the flow of the backend components. What kind of tool and technology I am using? I am using something called Client Code. This is the AI version of, I mean, this is similar like Copilot, but I like this Client Code. It's a little bit expensive, but helps me a lot. And the UI is TypeScript. Initially, I took Fire Studio's help, but then I couldn't scale with it. And I'm not a UI developer. My UI skills are very bad. So I need AI agent for this. And I also used a lot of different tools. Somewhere I found client code to be the best version of the um, AI agents that we have. And on the backend side of it, the main backend is written in Python. How I'm managing the sessions, how I am calling the APIs to Ignite, how I am doing timeouts, how I am integrating different components, session management, that's all written in Python. And logging and monitoring is done by simple Python utilities, simple Python tools, and cleanups are done by shell scripts and cron jobs. This part here on the backend side, there is no AWS, there is no cloud computing, there is no Kubernetes to be precise. Ignite itself uses Docker, so the KVMs that are getting created, these are actually containers, but that's not some code that I have written. That's the Ignite way of working with KVMs. So you basically get KVM containers, Docker containers with Ignite, and all you have to do is call the create or delete APIs of the third party. And yeah, that's about it. That's how we are managing it. As long as my backend is able to support, I don't have to pay anything to the cloud vendor because AWS provides you a free, um, I think 1 year subscription, 1 year, some 72 hours, something like that. You can keep your Nginx there. UI, yes, this can be tricky if you are comfortable with AWS or if you're comfortable with Kubernetes, then you manage this separately. Don't have, I mean, it's not a good idea to have this UI server inside the backend for the reasons just I said. So I've segregated my UI server is different, my backend server is different, and this is how I am using the DevOps-Xlabs. And there is an interesting part that I'm building right now, which is called this AI coach. So as of now, the labs that you see here, these labs are static labs. That means once I have written, they don't change. But I want them to be adaptive labs. So let's say you log in and you want a Kubernetes lab and you want to learn service and ingress. You also want to learn maybe Helm charts and you are an expert. So you get a personalized lab. So a dynamic lab is created for you, and that lab should be then available in the lab section here or somewhere within here. How it will happen? I will have another server created, or I will have another API. So Nginx is my the proxy. Here I have UI backend, and then I will have something here for the AI server setup. So the calls this can be directly calling the OpenAI, even though I know that I will not do it because that's going to be very expensive for allowing the users to directly call the API. So I will have in-house setup of API, maybe DeepSeek or Llama or something like that, setup done, and then I will ask the AI to interpret the input that we give from here, and based on the user previous, as at the moment I'm not tracking users' progress, but in this AI powered lab coach, I will track the user progress, and then I will tell them basically what kind of questions they should be practicing, and it's not going to be it's not going to be only related to a static content that I think is important. It would be updated by the AI mentors and AI controllers, right? That is some part that is missing. I'm also thinking to white paper this and provide this in terms of technical breakdowns, like a README guide, so as to say. I have it in my GitHub project, but I don't think that is in a presentable format right now. Let me see where it is. Okay, okay, okay. No. I'm not logged in. Sorry, my bad. Let me log in and then show you. Am I logged in here? Okay. Anyways, I am not logged in right now, so there is a project README that I have created for this. The repo is private, so I cannot show you, but that is something that is pending on me. I will create that. All right. Hope you guys found it useful. It gave you some context about the architecture that we have, some context about the API calls, and keep using it. Keep making use of these open source tools as well. Xtreme, KVM, Firebase, and Cloudflare. These are the backbone for DevOps-Xlabs. And be generous to donate to the labs because your labs and your donation is what helped me purchase these underlying servers. And that's how we are keeping it free. And yeah, goodbye. Thank you. I'll see you in the next lab.